Hello, my name is Nigel Letherby. I'm the training manager for Paratech Incorporated. Here to go over the structural collapse external. This PowerPoint presentation is for informational purposes only. It's not a substitute for hands-on training taught by a qualified instructor. Regular hands-on training is necessary to become proficient. Improper use of any equipment may cause serious injury or death. Think safe, act safe, be safe. Gravity is the external enemy of every building. Buildings are under constant stress. Building structural elements and connections make up its gravity resistance system. Gravity never sleeps. We construct the shores in structural collapse so we don't have to deal with gravity. It stops the building from moving around, and it stops the building from doing what it's intended to do. And that's go straight to ground until it stops and it doesn't move any further. Application forces. There are three types of forces in structural collapse: compression, pushing together; tension, pulling apart; and shear, material joint pushing and pulling. We deal more with compression. When we build the shores are under compression because of the building wanting to go to ground with the gravity side. Tension, we use tension in rakers when we put braces on the rakers. The struts are actually in compression, but the braces are more in compression and tension. Shear, the shear force is there when you've got a pre-stressed floor or a pre-tension floor where the cables or the bars are compromised and shear, and thus the floor pancake collapses. We use shear when we build rakers, and when we do a lot of structural collapse, it's in the picket system. The picket system will have a tendency to have the shear force application. This diagram shows the beam under stress, showing the beam under both compression and tension. If you take a look at the beam with the load is pushing the beam, so putting that beam into compression. The center of gravity of that beam is the neutral plane, and the underside of that beam, because it's held by 2 points, is the tension plane. So you get compression going on the top of the beam, and you get tension going on the bottom of the beam because it's trying to stretch that beam, whereas the tension part of the beam will mainly break or snap first. The double funnel principle, the foundation for all our shoring, and it will be the same in all shoring applications. It's just the triangles will move around to the different loads and the different angles of the wall, the floor, or the ceiling. The header collects the load, the post supports the load, which is the Paratech, or the 4x4 posts, and the sole distributes the load. Shoring classifications. We've got a class 1 shore, which is a temporary one-dimensional shore with no lateral bracing or stability. Your T-shore or your spot shore. The class 2 shore is a shore with at least 2 posts that are cross-braced together. Double T, horizontal, window shores. Class 3 is your 3-dimensional shores. Lace post, rakers, and slope floor. Class 3 are the strongest and most stable shoring systems that you can get. Solid and split sole raker. For your external structural collapse, the rakers are normally built on the external part of the building. If you take a look to the raker on the left-hand side, that's your typical solid sole, cross-braced with a K-brace on there. The middle one is a solid sole with a double X on the raker itself. And the one to the right, the one leg, is an actual split sole raker made from the Paratech equipment. The split sole raker is mainly the most common they use now, and that's because of the debris falling off the top of the building or off the wall of the building. That creates a pile where your shore needs to be. If you take a look at the picture all the way to the left, the solid sole with the K-brace on there, with the Paratech braces, the bottom sole strut can be raised up 2 holes. That'll give you a small slope floor shore, or sorry, a small split sole shore. It's hard with a tongue twister. If you take a look at the junction by the 12 by 12 blade base, that's your limitation. So how far up that sole shore can go on that rail. So it'll go up 2 holes and no further. The flying raker, the fastest and easiest raker to put up. If you take a look at the one on the left, you've got a flying raker there with your 3 lateral braces and your K. The center one, you've got a flying raker with your 2 lateral braces and 1 diagonal. And on the right, you've got your flying raker with a double X made out of 2x6 with a solid sole or a split sole raker made out of wood alongside it. Rule of thumb, if my raker is over 11 feet, then I need 3 lateral and 2 braces. If my raker is under 11 feet, I just need 2 lateral and 1 brace, 1 diagonal. Corner rakers. Paratech's about the only manufacturer out there that can build corner rakers. As you see, it's a weird configuration, but a configuration we can put in many application configurations. The one to the left, we've got 1 lateral brace on top. Then we've got the flying raker going into the wall. Then we've got a long lateral brace at the bottom, split up by 2 diagonals going to your flying raker. If you take a look, we got different levels of where your bases can go. 1 on the grass, 1 on the concrete. The middle one is showing that you put a corner raker together on 2 levels. 2 surface levels that the raker's on. We've got 1 small lateral brace on top, 1 lateral brace on the bottom, and 1 diagonal. The reason we only got 1 diagonal on that is because the rake is under 11 feet. The one on the right, we've got 3 laterals and the cross brace has not been put on yet. But it's just some of the things you can do to help to shore up just a corner of a building. The corner of the building may be the only thing that's compromised. So why build 2 full raker systems, 1 each side of the building, to shore up the corner when you can actually shore the corner up with just 2 legs? Rule of thumb, going back to the rule of thumb with rakers. If your raker length is under 11 feet, and that's the raker going from your 12-inch by 12-inch base plate up to the rail, then you only need 2 lateral braces and 1 diagonal. If your raker is over 11 feet, the picture on the right, then you need 3 lateral braces and 2 diagonal braces to make a K-brace. Now we're going to go over the step-by-step procedure for building a solid sole raker system. This is a 45-degree solid sole raker at a 9'6" insertion or a 10-foot insertion. First, you're going to connect the rails using a splice plate. Then you're going to lay the rails on the side. Using the holes on the side, count up the number of holes for your insertion point. What you got to look at is the first hole on the rail is up 6 inches. Then every hole after that is 12 inches. So thus, if I've got a 10-foot insertion point, then my cup and my base will be at 9'6", well within my 2 foot of window below my insertion that your raker needs to be. Lay the rails on the side. Using the holes, count up the number of holes for your insertion point. If your insertion point is 10 feet, then count up 10 holes. That will give you 9.5 feet, like I just said. First hole is 6, every other hole is 12. Put the latch bases in the corresponding holes, 1 at base of rail, 1 at insertion point of rail. Use a cheat sheet on the raker rail to find out the length of the raker strut. Then with a strut and extension, place into the insertion cup. Always put extension to the rail first, then put longshore strut into the extension. Try to leave 2 foot of adjustment in the tube. Example, if the raker strut has a 14 feet long, then I will put a 610 and a 635 together. Then I adjust the thread out for 2 feet. That will give me a 14-foot strut, thus leaving 2 foot of the thread inside the tube and 2 foot outside the tube. This is important for different angles of wall. If your floor slopes off or comes up, or if you've got a curb to deal with and your base plate's got to go off the curb. That allows you a lot of adjustment in that tube. If you take a look at your safe working loads on the cheat sheet on the raker rail, it'll give you your raker length, your insertion point, and the total load on the rakers. A wooden raker gives you 4,000 pound per leg as a 45 or a 60-degree raker. A flying raker gives you 1,000 pound per leg in wood. If you take a look at the Paratech figures there, at 16 feet, we get 5,000 pound. At a 10-foot raker, we get 7,008. That's all with a 4-to-1 safety factor. Then you're going to attach the junction base to the threaded end of the strut. The square end of the junction base will have the word sole written on it. That goes to your sole strut. The other piece goes to your raker strut. Place the 12 by 12 base plate on the junction with the anchoring facing away from the wall. If using nailing pads, place them on the raker strut before you put raker into place. It's okay to clamp the nailing pads onto the threads of the longshore. It's an Acme thread, so it's a square flat thread. You will not damage the threads. Rule of thumb with both nailing pads and your lateral bracing made out of Paratechs. If you look at a wooden raker, you always use 12 by 12 gusset plates. One at your insertion, one at your point of contact when it makes contact with the ground. Your gusset plates are 12 inches by 12 inches. So if you take that and look at the nailing pad on the right hand side, that nailing pad should be around 12 inches up from that junction base. And the same with the raker on the left, that nailing pad should be around about 12 inches out from the rail. Then your center nailing pad is going to go in the center. Put the raker up to the wall. Then place the angle base under the 12 by 12 base plate. Then pick it in place, either using a 6 by 6 whaler or going through the holes in the base plate. Repeat steps for the other leg, then cross brace. The picture on the right is fully cross braced. The raker is over 11 feet, so we put 3 laterals on and put a backwards K. If you take a look, the flying raker on the left, we've got 2 laterals and just 1 diagonal brace. If you see the diagonal brace on the left-hand side, you'll see there's an extension on the brace. That is acceptable. You can still go with the rule of thumb with 1 extension per gold strut using the braces. The one on the right is the flying raker with a double X made out of wood on the raker itself. This time we've got a 60-degree flying raker at 9-foot 6 insertion. This is a step-by-step procedure for building a flying raker system. First, lay the raker rail on its side and pick the hole you need to use for the insertion point, leaving at least 4 holes below the insertion point. Depending on the insertion height and the angle, put the raker together and extend for the desired measurement or the desired length. You're going to attach a B23 latch base and clamping clevis to the rail and raker. Depending on what angle you are constructing the raker, 45 or 60 degrees, is depending on what holes you're going to use in the rail. Count down 3 holes from your insertion point to give you a 45-degree raker, or 4 holes for a 60-degree raker. Now this information is actually put on the new label that's on the new raker rails. This information is on there so you can actually build the flying raker to your desired degree. Put the raker up to the wall, then place the angle base under the 12-inch plate Pick it into place, use a 6x6 whaler to go through the holes in the base plate. Repeat steps for the other leg, then cross brace. That is the end of the slideshow. Now Joe is going to show you a video of the actual raker being put into place. Thank you.
Hi, my name is Mike Uleberry. I'm your Western Regional Sales Manager for Paratech. Thanks for joining us today. I'm going to address one of the questions sent in by someone who had registered for this webinar regarding what are the options for midpoint bracing when using the Paratech raker system. So depending on the equipment you have, there are really 4 different options that are out there that I've used. The first one would be if you have the rail latch junction, then you can put that, if you're doing a full raker, on the bottom of your wall plate. And then that gives you the option to have your sole strut in, as well as put like a B57 up in, directly up into the raker strut, so that you have that midpoint bracing, breaking that down into less than that 8-foot increment. If you didn't have that, another option would be you could take B57 with 2 clamp clevises, put one on the sole raker and one on the raker strut, and accomplish the same thing. Another option would be to take another rail junction latch and pin that above your sole strut, and then put a B57 with the clamp clevis up to the raker strut. And then the last option would be you could go back to your B23 struts that you have that you use in your flying raker, and you could put that down and pin that into the wall plate. You might have to put like a 235 extension on that, but you could push that out and clamp that on similar to a flying raker, as long as you broke that up into a less than 8-foot increment. Doesn't necessarily have to be a perfect triangle split on that, but it provides the same midpoint bracing strength and accomplishes the same goal of the midpoint brace. All right, now we're going to move to a video on the raker construction. And once the completion of the video has occurred, if there's any other further questions, we'll address those.
A brace is indicated by the prefix B before the number. The difference between a Paratech strut and a brace is the struts are designed to be used in compression. Braces are designed to be used in tension. So the collar of the brace is permanently attached to the tube. To adjust the brace, you spin out the piston. The collar does not move. Here we have 6 extensions. 2 235s, which are 24-inch or 2-foot extensions, 2 435s, which are 4-foot extensions, and 2 635s. The 6 indicates the length in feet of the extension, and the 35 stands for 3.5 inches in diameter. The gold struts are 3.5 inches in diameter, and gray struts are 3 inches in diameter. Here we are measuring to our insertion point. The insertion point is the point of damage that we are trying to capture with the raker system. So at this point, he's going to take the measurement and relays this measurement to logistics. They will assemble the raker based on this measurement. After taking the insertion point measurement to the raker table on the raker rail, they will decide then if a 45-degree or 60-degree raker will be erected. In this case, they will build a 60-degree raker. They choose a lower raker table on the rail and slide their finger along the second column until they find the insertion point measurement of 10 feet. Now they slide their finger to the left column. That will give them their raker length. In this case, a 10-foot insertion point will give them a raker length of 12 feet. Here are the 5 components you will need to assemble one portion of the raker without putting in the bracing. Here is a 610 strut. To the right is a 435 extension. A 610 strut is 6 feet collapsed and can extend out 4 feet to a total of 10 feet. The 435 extension is 4 feet long. We will take a 610 strut, add a 435 extension that will give us 10 feet. Then we will extend the strut piston by 2 feet and lock it. Then we have our wall plate, raker latch base, and ground pad. So at this point, they will bring the strut down to the extension and set it down. Remember, yellow tape to yellow tape assures that the extension goes on the correct end of the strut, the non-movable end. Now assemble the two pieces. Pull up the lock pin, set it, and let the lock pin go. The assembly is locked together. Here we see one end of the latch base is solid and one end is movable and spring-loaded. The solid end goes in first, and then the spring-loaded end. Once the latch base is locked in place, turn the raker rail on its side. Attach the strut to the wall plate via the latch base. Next, attach the wall plate to the raker. Notice the yellow tape. The yellow tape always goes towards the wall. Now attach the two pieces. Move to the bottom and attach the base plate. Remember, the length of the raker has to be 12 feet. They have a 6-foot strut with a 435 that is 10 feet. Extended approximately 2 feet. We don't have to measure because it is adjustable by spinning the lock nut. Take the base plate with the D-ring and assemble it to the bottom of the raker strut, making sure the D-ring faces outwards away from the wall. Now assemble the bracing. Use a B23. The B indicates it is a brace. For a 60-degree raker, leave 3 open holes on the wall plate. Attach the raker latch base to the 4th hole. Remember, yellow tape goes to the wall. Take the brace with the yellow tape and attach to the wall plate. Attach the clamp and clevis to the movable end of the B23 brace. Let this hang unattached to the raker strut. Move the assembly, with the brace not attached, over to the wall. Slide the top end up the wall until you reach the 10-foot insertion point. At the 10-foot insertion point, the man at the bottom will adjust the lock nut on the strut standing on the ground pad, footing it. Footing it will hold the raker in place while the brace is adjusted and attached to the raker strut. Now attach the brace to the raker length. Bring the B23 up and make a 90-degree angle. If it is not exactly 90 degrees, spin out the piston to make the clamp tight so the gap in the back is filled. When tightening the butterfly nut on the clamp and clevis, make sure the washer is on top of the clamp. Turn down the butterfly screw hand tight. Make sure there is a 90-degree angle between the wall plate and the brace. Remember, the wall plate must be pinned to the wall in 2 places to prevent the raker system from sliding up the wall. There are 1/2-inch holes in the face of the wall plate to facilitate this. Since this is a block wall, we can use devices designed for this like Hilti anchor bolts or concrete screws. Using 2 bolts or pins will prevent the raker system from twisting. Put one down low on the wall plate. If they go up higher, put in a second one. Now that we have our raker attached to the wall and the angle is correct, pin the base plate to the ground. Pinning it to the wall will prevent the raker from sliding up the wall if the building starts to move. Pinning it to the ground will keep it from sliding away from the wall on the ground. Pin it with 2 pickets, which is normally the way we start. We can always add a whaler system to the back later. If a wooden raker is assembled next to this system, it can be braced to the ground using a whaler. This flexibility is designed in the system. We always place our pickets in the 2nd hole from the back. That way, if a wooden whaler is used afterwards and added a wooden raker, they can slide in the angle brace and fit it right around the picket. Now slide in the whaler against it. That way the base plate cannot kick out under the whaler. Now a wooden raker can be built. Use wooden wedges between the wood raker and the whaler system to pressurize the raker to the wall. The Paratech system can be taken down and moved down the wall to another location. The second assembled raker is set up at 6 foot on center. Because we're placing wood rakers on either side and want them to be 8 foot on center. As it is brought into place, they will slide up the wall to match the other one. Take a measurement and set it up to 6 feet on center. We have put our raker up 6 foot on center. Because we will assemble a wooden raker on either side and want our wooden rakers to be no more than 8 feet apart. Here are the components for the lateral brace. A B57, which is a brace and 2 clamp and clevises. Attach the clamps and clevises on both ends of the B57 and extend the brace out so the center of the clamps and clevises are at 72 inches or 6 feet. That means when they attach the lateral bracing to the raker assembly, it will fit perfectly. Now take the clamp and clevises and attach it to the non-movable end of the brace. Attach the clamp and clevis to the movable end of the brace. Because our struts are 6 feet apart, we measure so the center of the braces are 72 inches or 6 feet. Extending that out, attach it to the raker system. Notice here on the left, the non-movable side is always attached first and locked into place. The middle is put in first to stiffen everything up. Slide the other end up, making sure it is level and parallel to the ground. Hand tighten the butterfly screw to hold it in place. The center lateral brace, one of 3 lateral braces, has firmed up the entire assembly. It will keep it together while placing the others. Now insert the second of the lateral braces. This brace goes on the bottom, approximately a foot from ground. Notice again the non-movable side goes in first and is going on the threads. It is permissible to clamp on the threads or onto the tube. It will not damage the threads. We now do the same thing on the opposite side, the movable side of the brace. Clamp the jaws around the raker, slide it down into place, close it over and hand tighten up the butterfly screw, making sure it is level. Now assemble the diagonal brace, which is longer than the lateral brace. The lateral brace was a B57 by itself. The diagonal brace is going to be a B57 with 235 extension. Notice the matched yellow tape to yellow tape to make sure the extension went on the correct end of the brace. Attach the clamp and clevis on the non-movable end. Move up and attach the clamp and clevis to the movable end. Then move the device in and install the first diagonal brace onto the raker system. Take the adjustable diagonal brace that was assembled and attach that to the bottom of the rake first. Notice they always attach the non-movable or non-adjustable end first. Take the adjustable end and slide it up, turning it out to adjust it so the clamps and clevises are tight together, turning the butterfly brace. Next, attach the top lateral brace. Take the clamp and clevis, and at the top of the strut there is a shoulder. Slide the brace up. Again, we're attaching the non-movable end first. On the left-hand side, notice it is attached even with the shoulder of the actual strut. Take the adjustable end and slide it up, opening the jaws to get it to fit over the strut they're going to, up to the strut shoulder, the top shoulder of the clamp and clevis. Match it to the shoulder of the strut and hand tighten. Once complete, we are now ready for the next diagonal brace. Bring in the last brace to the system, which is the second diagonal. Again, attach at the top the non-movable end, non-adjustable end first. Bring the clamps and clevises up to the top right as tight as possible. Once tight, attach the clamp and clevis to the bottom. Here's the completed Paratech Absolute Raker. There are 3 lateral braces and 2 diagonal braces, which make the K brace.
All right, seeing no further questions, I want to thank you for joining us today for this episode of our webinar on shoring and rakers. Please tune in 2 weeks where we will do another webinar on interior clap shoring. Thanks again. If you have any further questions that come up, please reach out to your local Paratech representative.